me put. Screen. Okay, so got a question. Can you submit via email? Yeah, if you are not gonna come to class today, you can submit via email. Any other question? Okay, so let's get started. Okay, so I want you guys, I mean, I've been following the performance of the students in class, and some of you are doing well, some of you are doing very well, and some of you are not doing very well. So, so we're still on time to improve the performance. You still have another simulation exam and also another class theory exam, and also you have the project. So today you're submitting the second report. And I'll be grading that. You'll have a better idea of where you are after the project report. What I'm trying to say is, at the end of the semester, the grade that you're gonna get is the grade that you earn. Okay, so hope that that's clear. Okay, so is the grade that you're gonna earn the grade that you're gonna see in the final report. I'm sorry, in the final at the end of the semester. Hope that makes sense. So let's start with the discussion. Lab 8, modeling analysis of manufacturing systems. And today we are going to discuss on lab 7, we were talking about schedules for arrivals. Today we're gonna learn how to use schedules for the resources. Meaning that if you're working in a manufacturing facility or any system that in which you have schedules for your staff, you know that some of those schedules are going to be changing throughout the day. Meaning that at some point you might have 2 shifts running. At some point you might have only 1 shift running. Number of people will change throughout the day. You have 4 staff members from 8 to 4, and then after 4 p.m. you can have only 2 staff members. All those things are possible in your facility or in your manufacturing process. So the idea with this new skill that we're going to teach today is to be able to model those situations in which you have changes in your staff during the day and you want to model that as part of your system. So far, we have been modeling systems in which we assign a capacity to our resource and that capacity never changed. So if we have capacity of 2 for the machines, that's going to be the same capacity throughout the simulation run. If we have an operator, there's only one operator through the simulation run. With the technique that we're going to teach you today, you're going to be able to change the staff or the capacity of your resource according to the scenario that you are representing or according to the needs that you have for your system. So that's the idea for today's lab. Yes.
Cashier and the cooking time or the food processing, we don't
separate them.
Yeah.
No, it's okay.
It's okay.
Yeah. So it will depend on your system. Like if you know that the processes are separate and they are like different and they're changing. For example, you processing time for cashier, maybe you have one cashier right now and then at some point you have 2. So those processing times, they need to be separate. You don't want to have the cooking time being changed because you have 2 cashiers or 1 cashier at a time. So it will depend on the system.
Like the number server 2, the cashier sometimes stays and sometimes stays. So I haven't calculated them separately.
So what you have is a person that put the order together and then also charge the customer?
No.
So you have a cooker in the back and then
No. The food is already prepared. They just ready the food. They just make this, put it into the bag like order.
Okay, so is the cashier doing that?
No. And then not the kitchen, I think there is.
So there's another person putting the order together? Okay.
So what is the like for our one they are we are taking that and for the order taking placing what is the type of one all the server. I didn't can put individual cashier, right?
We'll have to look at the report and then we can discuss offline because I wanna.
You are discussing that? I thought we discussed the report.
Oh no, what I'm saying is if this discussion is gonna take longer, then we can talk after class because I want to focus on the lecture and then after class we can talk.
Yeah.
Okay. So we're gonna be looking at the schedules for resources. So I'm gonna go straight to the new material for today. Okay, so here. So resource schedules, this allows you to define resource capacity based on a daily time or calendar. For example, the capacity of a resource changes according to a specific schedule. So this is going to be changing the capacity of a resource. And what are the parameters that we are going to need? We are going to need the name of the schedule. So in our case, or in this particular scenario, we're going to have a schedule that is associated to the capacity of the resource. So that's why this is marked here, capacity or the capacity of the resource. And then we need to know what are the time units. So if changes are going to happen every hour or hourly, we're going to use hours as our time unit. But if you know those changes can also happen in between hours, like half an hour, we also have the flexibility to accommodate those scenarios. So time units, it will depend on the type of how changes are happening in your system. So for example, here, this is a picture. You can see here we have a graph. We have the time periods, hourly time period here at the bottom in the x-axis. We have day one, and then every hour you see for the first 2 hours, we have capacity one. Capacity is in the y-axis. Maximum capacity that we observe is 10. But you see how the capacity of the resource is changing throughout the day. So at the beginning of the day, we only have one. Then after a couple of hours, we have two. Then after 3 hours, we go up to three. After 4 hours, we go to four. After these many hours, you go to five, and then goes down to four again, and then goes to six, then goes to three again, and then goes back to two, and then we close. So this graph is showing you the difference in changes that are possible through the simulation run. For example, if you have a lunch break, let's say you have a lunch break at 12, you can also represent that here in the system. You can just put capacity equal to 0 if you have a staff member that is going for lunch. And then during that hour, nothing's going to happen because that staff member is not there. Work is going to resume after the operator goes back to work. But that being said, we also have an additional challenge. Let's talk about how to code the schedule. So once you define, like we did for the arrival process, you define the table with the number of time periods and the value for the capacity in this case. We're going to go here into the resource module, and we're going to change the capacity or the type from fixed capacity to based on schedule. And then we're going to find the name of the schedule. But this is what I was heading to. Let's say you have an operator that's working on a part, and then the time of lunchtime arrives, and then you had 3 things that can happen, and those are listed here as rules because we can model those. So let's say you are the operator and you start working on a part, and by the time that lunchtime is here, you have not finished the part. So what do? Do you stay with the part until you finish and then go for lunch? Do you leave the part as it is and then you complete the part after you're done with lunch? Or so those are the 3 rules that let's read through them. So the first rule is ignore. The resource requires maintenance when finished with an entity and loses downtime based on how long it takes to finish. So for example, a carpenter is making a table. If he has not finished the table by the time his break starts, he must finish it. So what this is saying is you're gonna ignore that your lunchtime has started. You're gonna need to finish that product before you can leave. But you're not getting that time back. Okay, so that's what this is saying. So if you have an hour for break and you finish the table, and it takes you 15 minutes, then you're gonna have 45 minutes only for your break. When he finishes, he may have his break, but must return to work at the scheduled time. So if you use ignore, that's what's gonna happen. If you're working on a part and you have not completed by the time that the break is here, the model is gonna force the entity to be completed before the resource can be released. But that person is not gonna have a 1 hour break. It will come back at the scheduled time. We have the wait. Here the resource requires maintenance when finished with an entity and requires specified downtime. So this is the opposite. Well, it's the same thing, with the only difference that you will have your entire break if you use the wait. Meaning that if you were supposed to go out at 12, but you stay until 12:15 because you were completing a part, then instead of coming back at 1, you will come back at 1:15. So even though you stay, you get the whole hour for the break time. And then you have the preempt, which is basically the resource required maintenance immediately and requires specified downtime. So example, a paint sprayer is spraying a car, suddenly runs out of paint. The sprayer must immediately be serviced for a specified period before it will be called back to operation. So what this is saying is, okay, you need a break. You are not finished. You're gonna stop the work. You're gonna go take the break, and you will come back and then you'll finish. So those are the three things, and they're different, and that will impact your results. So you need to know what type of process is happening in order to make the best judgment and decide which of these three rules are used for your case. Ignore, wait, or preempt. Okay, so that being said, I think the rest is being covered, so we can go straight to our scenario for today. So in this example, we have a 24-hour process. We have an arrival process that's happening following an exponential distribution. And then we have two machines that are processing parts. 50% of the parts will go to machine 1, 50% will go to machine 2. They follow a uniform distribution. And then we have 3 shifts in this process. From 8 to 4, we have both machines working. From 4 to 12, we have only one machine 1 working. And then from 12 to 8, we have only machine 2, or both of the machines, I'm sorry, working. Also, routine maintenance is performed on both machines at 5 p.m. And the maintenance takes 30 minutes. Okay, so we want to include that in our program, and we want to compute the mean number of parts per day. Oh, so this is saying that machine 1 is working during that time period. And since there's no X here, that means that it's not working. Yeah, sorry about that. So we're gonna run this for 10 replications, and each replication will last 10 days. Okay, and you see here, routine maintenance is performed on both machines at 5 p.m. So that means that we have to have 30 minutes down here for machine 1. But for machine 2, we don't have to worry because that's gonna happen during this time that the machine is down. Okay, so let's work with Arena. Okay, so I'm saving my model. Make sure that you save your model before you get started. And then I'm going to go to our regular modules, advanced process, and basic process. And we're gonna start with our create block. Okay, and this follows an exponential distribution with mean 5 minutes. Okay, so we have our create block. Right. And then we are going to split this. Actually, let's do the assign first. We know we're gonna need an assign block here to compute the working process. Number in the system, average number in system, so the working process. No cycle time, just working process. So we are going to define that variable. Or let me call it num in system, just to be consistent. Num in system. Just one, yes. No cycle time. Just num in system. Okay, so what's next? What do we need to do now? We had to split the, yeah, so we need a decide block, right? So let's do the decide. And this is gonna have the 50% chance, so we don't have to edit this. And then we have the machines, right? So we're gonna do a process for each machine. Okay, so here's where we need to stop and think about how we're gonna model these schedules. So let's go back to the information here. So I need to discuss something here. I want you to pay attention because this can create problems in your models if you don't do this correctly. So when you're running a 24-hour process like the one we're showing here, and you define a schedule, for these type of situations in which you have this empty space here, we have to be careful. The reason why is if you choose 12 a.m., actually, this goes up from 12 to 12 a.m. Let me create a new slide here. Okay, so this is your schedule. And let's say this is 12 a.m. and then until 8. Let's say this is 24. Oh, 12 p.m. So this is the end of the day, right? So this goes back to the beginning. In the model that we are seeing that from Okay. So you have a capacity of 1. Up to here, right? And then after that, it goes back to 0. Right. So this is for machine 2. So it's going to be 1, and it will go to 0 after that until 12 a.m. and then you go back to 1. The problem with Arena is if you set up your schedule to start with, remember this table here. I don't remember where's the label. Let me find that. Value and duration. Value and duration. If you just do something like this, so in this case, you can say 1, value of 1 for 12 to 12 is 12 plus 4 is 16, right? Yes. If you do that, what the Arena is going to do is, as soon as you complete this 16 periods, it's going to repeat the schedule. Okay, so it's going to run the same schedule over and over. It's not going to do the 0 at any point. Okay? Because the way it works is going to read the schedule, it completes and it's going to repeat that schedule, it's going to repeat that schedule, it's going to repeat that schedule. So, and that's why I want you to be careful in identifying your time 0 for these situations in which your capacity goes to 0, because if you do this, what I just did here, is not going to represent what you're trying to represent in the system. So the way you would address this is by identifying another time 0 for your system. For example, you can use 8 a.m. If you use 8, you have a capacity of 1 up to 4 p.m. Then from 4 p.m. to 12 a.m. will be 0. And then this will be 8. So this will look like this. And your table will be how many hours? 8, right? I'm sorry, this is 1 for 8 is gonna be 8, and then 1 again. Yes. So this would be the right way to program what we are trying to model in our system. If you go with the one at the top, the Arena model is gonna repeat that 12 to 4 p.m. without taking into account this time period of 0. But if you program that like at the bottom of the slide, which you split these time periods and you have the 0 in between, then it will know that you have a time period in which there's no one in the system. If you put 0 here, it will not, and I agree with you, but it will not work. I mean, we can try it and you'll see how that it won't work. Yeah, so essentially what you're trying to do is to make sure, yeah, put the zero in between. So you're making sure that that time period in which you have a resource, no resource is considered by the system. And that's one of the, I don't know if they have fixed it with the latest edition, but that's one of the issues with the software. If you don't know about this, you will see that the results are not making sense. So knowing this, then we can go back to our model. We can define our schedule. So we're gonna call this machine one schedule. And for machine one, we look at this. Sole use, right? But we have a maintenance of 10 minutes happening in between at 5 p.m. So we have to use half an hour as our time periods. So in time units, I'm gonna use half hours.
Normally, like 4.5 hours.
No, that's not gonna work. You have to specify the time periods. Okay, and now based on that, we can establish the. So we know it's gonna be 1 and then 0 and then 1 again. But we need to know how many time periods. So we are using 8 a.m. as time 0. So we'll go from 8 to 5, right? How many hours? We have 9 hours, right? Times 2 is 80, right? So this will be 80. And then we have half an hour with 0. So 1 time period. And then the rest go from 6 to 8, 19, right? In 19, 29, right? So we go from 8 to 5, that's 18 time periods. Then we have 1 time period for maintenance at 5 p.m. And then we go from 5:30 to 8 a.m. Those are 29 time periods in which we have capacity of 1. And that will be machine. That'd be AC. First time that I noticed the sound. Yeah, schedule. Okay, so for this one, we can do hours, right? Because maintenance is gonna happen in between. From 4 p.m. to 12 a.m. Our machine is down, so we can do the maintenance without problem. So for this one, we can do hours. And then we're gonna have also 3. And we're gonna use the same time as our time 0, which is 8 a.m. So we're gonna do 8 hours, 8 hours, and 8 hours. We're gonna be up and running for 8 hours, then down for 8 hours, and then up for 8 hours. Questions? Okay. So now we have to go and define our resource. Cease delay release for machine 1. And the probability distribution is uniform 5-7. We're going to use a uniform in minutes. 5 and 7. Excuse me. And then for machine 2, uniform 7-9. Yes. Oh, sorry. I didn't define that. This is machine 2. Okay, so we have the machines already defined in the process. Now we need to assign the schedules to the machines. So I'll go here into the resource module here in the basic process. I click there and you'll see this window here. We're going to change that to based on schedule. And we are going to identify machine 1. You see there's a schedule rule there. You remember the difference between them. We have wait, we have ignore, and we have preempt. So wait, you're gonna take the whole hour, but you have to complete the part that you have on hand. Ignore, you're gonna complete the part, but you're gonna reduce your time for the break. And preempt, you're gonna stop, take the break, and then complete after you come back. In this particular problem, we have not specified a rule, right? We don't have the details. So we're going to keep I'm going to keep wait because it's the default one. But for the assignment, you'll see that you're going to have to use one specific rule in the assignment, okay? So I'm going to assign the schedule also for machine 2. And that will be it for the machine. And now we can do the next assignment. in which we are going to now call the same variable nomin system. And we're gonna reduce that by 1. Every time we had an entity crossing that block, we're gonna reduce that by 1. Okay. And then dispose, yes. Okay, so let's set up the statistics. We are gonna do just the working process or nomin system in this case. So this is a time persistence statistic. Nomin system. You have to define the label. I'm gonna call this in.
Solve the problem. What will be closing?
It's closing? Oh, no, I'm using a different computer. Oh, yours gone? Oh, no. Yeah, I know there's some issues with. So I mean, it's the same computer. In my case, is the same computer is working in one and it's not working in the other. So not sure what it's weird. Yeah. So let's check. Let me check my model and see if it's gonna work. Yeah. So let's do the setup. This is 10 replications. Yes. For 10 days. Base time units is minutes. And then the project parameters, I'm going to uncheck all this. And for the report, you're getting an error for the, are you getting the same error? Mine is saying that it's maximum number of entities being exceeded. And this one? Okay, let's see. Yeah, at some point it will go down, but it should go back up because of the, yeah. See, that queue might go above the limit.
Okay.
So once this one reach 150, you will stop, right? Well, process 2 will be down for 8 hours, remember? So I think that's what's creating the problem. Yeah, we'll exceed it at 6,000 minutes, I think. Yeah, there you go. Yeah, that processing time for the second machine is too high. Let's change that to let's make it faster than machine 1. So make it 2 to 3. Yeah, it's because we are not forcing when the machine is down, we are not forcing those entities to go to 1. We're just accumulating them. So if we do 2, 3, I think it runs. Yeah. So machine 2, we're making the uniform 2, 3 instead of 7, 9. Because we have the student version. So if we have the academic version running in your machines, it will be no problem. Okay. So I got 12.245. Is that what you got? Okay. What about the students online?
Good to go.
Okay. Yeah, I have another student here in the classroom that's facing issues not working with the arena. So I think we are gonna have to rely on the machines in the laptop car for now on. Maybe next time we can use one of those machines for the assignment. What about, you have access to the third ones? Do you have arena there? Okay, okay, okay. Now, because the other option you have is to remote desktop into that machine. So if you have access to, if you have a computer in the lab already assigned to you, you can request to remote desktop to the machine. And then you don't have to be here to work from that machine. Yeah. Yeah. Okay, so questions about this? No questions? Because on the assignment, you're gonna have to work with the schedules for the capacity of the resources. Also, remember that you have different rules. So for the rules, you have to assign one of the rules to each resource in your lab. So if you don't remember what what rule to use, you can refer to the slides. The slide 45 for today, it states the difference between the rules. So you can check on this before making the decision. Have a message here. Yeah, so for Tom, you can also discuss with Dr. Dong about your access to the lab. Maybe she has the computer arena in one of the computers. And if that's the case, you can do remote desktop to one of those machines. So that would be my advice, just to make sure that you can still work on the assignment, that you can remote to one of the machines on campus, and always have access to the software. Any questions? Okay, so that's all for today. So if you have other questions, I'll be available during my office hours. Today at 3:30, or you can talk about, I mean, I'll be here for a few minutes if you need to talk to me here in the classroom. So, thank you.
Thank you.